Hello, welcome once again. I wanted to go over series circuits, parallel circuits, opens and shorts because I received comments about those things. There's some confusion. It's a difficult content to explain. However, let's try. The basic circuit. We're dealing with one bulb over here. We have a power supply over here, our famous automotive battery. And the positive is connected here through conducted through wires. This filament, this bulb has some resistance in it. In this example, 6 ohms. So what travels through the wires is here. Current flows from the positive through here, through the conductor, through one side of the filament of the bulb. It comes out the other side and back to the battery. Basic rule over here, as we go through the video, you have to have a complete path for current to flow. If this wire is cut off or open, current cannot flow to light the bulb. If this one is open, current cannot flow to light the bulb. Doesn't matter this one, doesn't matter if the bulb itself is burned out and it's open. There has to be a complete path. If I leave the positive, I should get back to the negative for conventional flow. If electron flow, if I leave the negative, I should get back to my destination, the positive. That's the rule, and that's the foundation now that we're going to build on doing these type of circuits. Okay, now, let's go to a circuit over here. Okay, let's take the basic circuits over here. Now, these are resistors, the symbols for resistors. They each have a resistance over here, 1 ohm, 4 ohm, 2 ohm, 5 ohm. Again, famous 12-volt battery that we have. Instead of resistors, let's put bulbs here. This will be one bulb, another bulb, another bulb, another bulb. 4 bulbs in series. These are called series. Let's do the shorts and let's do the opens. Now, open circuit. This over here is an amp meter. If this is open, this is a series circuit. If this is open, right, no meter is connected here. He's showing you, he wants to put in a meter to show how many amps he's measuring. Current flow. So in other words, 12 volts over here, you have 12 ohms resistance. The total of all the bulbs together will give you 1 amp. 1 amp leaves the battery, goes through one resistor, one bulb, let's say, one bulb, one bulb, one bulb, one bulb, back to the positive, or the positive going back to the negative. Doesn't matter the flow, the direction of the flow. He takes this meter out. Now it's open. These are bulbs. Which bulbs will light? If you said all of them, you're wrong. No bulbs will light. Once you have an open over here, why? Because current has to flow through the bulbs, and what do we say? Back to the battery. Can it do that? Nope, not if there's an open here. This is the rule. Remember, if there's an open, if this bulb was open out of the 4, that's it. Current cannot flow. If this bulb was open, even though the other 3 are good, nope, current cannot flow. Current has to have a complete path back to the battery. That's the rule. Again, we're building on that concept, on that theory, on that logic. Okay? Now, we just said if this is open, any one of these is open, screws up all the other bulbs, or resistors in this case. Wherever the open is, the open can be here, the open can be here, the open can be here. It doesn't matter. Current looks and says, okay, the voltage says I have to send 1 amp, but 1 amp has to leave me and has come back to me. Fine with that concept. Okay, now current does not flow and say, okay, well, there's an open here, I'll wait over here until you fix the open or you change the bulb. Current doesn't do that. Current says it's either one, it's all or nothing. I have to leave this and get back to the battery. Now, let's go with a short. And this was where the confusion was. If this is 4 bulbs, and these are in series, obviously, right? Let's say each resistor represents the resistance of each bulb of the filaments inside. Let's say I have a short across any single one of these. Do the lights light? And the answer is yes. Let's go over that. And this is why I have, instead of using the pointer, I have to use a marker for this one. Okay, a short meaning, let's say I put a jumper across here. I put a jumper, oops. I put a jumper across here. A jumper wire. Current comes out of the positive, goes through the meter, comes here, and this lights, correct? Let's say this is bulb 1. Bulb 2, it lights. There's a short across this. Guess where it's going to go? It's going to go into the short. It's not going to go through here. So this bulb is not going to light. Comes out here, and then this bulb is going to light. So what did the short create? It bypassed this filament, this bulb. But all the other ones can light. Okay? Let's say now, instead of the short across this one, we put the short across this bulb. Will the other ones light? Yes. It will just bypass that bulb and go through the other ones. Like we said. If the short, if I take a wire, put it across here, current will flow into the wire, not into the bulb, and light up the other ones. That's a series circuit. Let's take that logic, because always current wants the path of least resistance. Remember that rule. Let's go a little into parallel. Okay. Opens and shorts. This is called the parallel. Okay. All the bulbs that we have are in parallel circuits, like I showed you in the book. Let's say these are bulbs or resistors. The problem with parallel is it depends where the open circuit is. For example, we still need a path back for the current to come back of a complete path. It doesn't matter if it's series, it doesn't matter if it's parallel, it doesn't matter if it's series parallel. This current has to flow, let's say, leave the positive, right? Divide between these two, and eventually they'll meet over here and come back to the negative. That's the rule. That's why I started out with that rule. Let's say this one over here opened up on us. Let's say there's 4 bulbs. Okay, I wish these were bulbs instead of resistors. It would be easier to visualize it, but it's okay. I think you grasp an idea of it. Let's say this is open. What happens to the current? We still have that rule in effect. Current has to flow back. So the current comes to this point. There's a connection here, and it says, okay, I'm going to split up, right? But guess what? This is open. The current doesn't take this path because it's open. The current takes this path, goes through here, goes back to the minus. So this is out of the picture. As long as the current has a path for it to go back to the battery, it's okay. Even though it's going to affect the brightness of it or whatever of the resistance will change, the total resistance will change of the. We're not concerned about that right now. We're just dealing with now opens and shorts, how it affects the lighting systems. So we're going to go here. This one says it's open. I'm not going to go there. Let's say if this one is open, this bulb open, this resistor open. Current comes here and says, okay, I have 2 paths again, but this one is open. I'm not going to take this one. I can't go there. It's open. It's like a drawbridge that's open. You can't cross over it. Current can flow in this one. Why? This is a complete path. Okay? Let's say the open is here. Uh-oh. Open is here. Can currents flow here and here? Current can still flow here back to the battery. The rule is in effect. As long as I have a path to go back, I'm going to use that one. The current doesn't care which one it is. It just says, give me a path to go back from point A to point B. I'm happy. He goes here. Of course, the resistance changes because now we have less than this 3 ohms together. Like I said, we're not concentrating on that. Let's say the open is here. Uh-oh. This is why I had to use a pen today. Open is here. Now what happens? Now we're in trouble. Current cannot flow to either paths. Current comes here, tries to come here, and says, you know what? I have no path to get back to where I wanted to go to the battery. It knocked out both. So you see, wherever the open is, if the open is here, 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 it makes a difference. Okay. Because this is common, this wire is common to both. We have a short. Let's create a short, then we're going to go to one more. We have a short. We have a short across this one. This is a short. Can current still flow? Current can still flow. Why? Because it still has a complete path to go back in this branch. Branch here, a branch here. The current can still go, skip over the 4 ohm bulb, go through the 2 ohm bulb, skip it, and go through back to the battery. As well as current can still go over here, back to the battery. It can still go. Like I said, the resistance will change. 4 ohms is out of the picture. Not concerned with that. Now, we have a short. We have a short across here. Will that make a difference? Absolutely not. It's just a wire. You're shorting a wire to a wire. Doesn't make a difference. Okay? Let's say you have a short across these two. Sorry, I couldn't draw it, better, but I think hopefully you understand. We have a short across these two. Now what happens, you think? Trouble. We just shorted out the battery. What did we say? Current wants the path of least amount of resistance. Which path here, this branch or this branch, has the least amount of resistance? This is 0 ohms across. I just took a jumper wire and I shorted out this. Right? This is not a complete short, a dead short. This is just shorting out the resistor. There's a difference. This is a complete dead short. Where is this connected to? Positive. Where is this connected to now? Negative. We just shorted out the battery. Bad. Right? This one shorts out just the individual resistor. Let's take another one, a series parallel, which was asked for me to do. So you see, it gets very technical and it gets very tricky. Electronics is not easy, but you just have to incorporate the rules. Now, we threw another resistor. This is parallel, right? And parallel with the series resistor of this. So now let's go over here. This parallel circuit over here. This is over here. Let's say this opens. This is tricky. Let's say we'll take this one out of the picture. Oops. Does current still flow? Let's say this is a bulb, there's a bulb, there's a bulb. Does current still flow? Current can still flow. Go here, here, here. Through this one. Through here. Let's say this open, but this is good. This open, guess what? Current can still flow through here. As long as it has a complete path. That's why I started out that video with that statement. Right? Let's take this out. This opened up on us. Uh-oh. Now, if these are bulbs, which one lights? If you said that this one lights, you're wrong. If you said that this one lights, you're wrong. None of them light. Why? What's the rule in effect? We have to get back to the source. Current goes here and says, okay, go through this resistor. But wait a second, this is open. I cannot get back to my destination. Can't flow. Current cannot flow. What about this path? Go through here. Current goes here. Same thing. Current cannot flow back because he is common to both. You see, it matters where it is. Let's take a short. I'm going to put a short right here across this one. What happens if I put a short across there? Can current still flow? Yep. Current will flow here through here. Current will flow here through this bulb, through this bulb. Let's take a short across here and here. Uh-oh. Now what do? We're just not shorting a resistor. We have a dead short. We just shorted the battery. Because this is connected back to positive. It's connected back to negative. Current will not flow here. Will not flow here. Guess what current will flow? Current will flow from the battery to this jumper wire and back to the negative. Because this has the path of least amount of current. Think of it as, again, traffic flow. I come to a highway. I come to two highways. right? There's a lot of traffic here. But when I get to this point, there's absolutely no traffic here. And you know what? They both bring me to the same destination, right? I'm going to take the path of the lane of least amount of traffic. There's no vehicles here. Forget about that. I'm going to go right here. Current thing's the same way. So again, shorts, opens, it depends where. I hope this was helpful and informative. Go over it because it's a lot of information. It's a lot of knowledge. But like I proved to you, it doesn't matter what type of circuit. We went over parallel. We went over series. We went over series parallel. Current has to have a complete path. Remember this. And it doesn't matter if it's a fuel pump. Doesn't matter if it's a wiper motor. Doesn't matter if it's a starter motor. Current has to leave the battery and come back to the battery with the same amount of current that it left. If it left with 3 amps, you see here, it has to come back with 3 amps. If it has 5 amps leaving it, has to come back with 5 amps. In this example, there's 3 amps leaving the battery. 1 amp goes this way, and 2 amps goes this way. Why does this have more current? Because there's less resistance here. 1 amp goes here, 2 amps goes here. What happens over here? They join together for 3 amps. 3 amps split over here. When they got over here, they joined together, and then 3 amps goes right to this resistor. So the most amps going through is through this resistor. Okay? Okay, thanks for watching. Go to my other ones, how to test relays and circuit. Please, Joe, Electronics Schematics for Auto. Thanks for the views going up and the watching minutes going up. It's great news, and thanks for the request. I'll try to get as much as I can for EVAP and other things. A lot of requests, a great thing. It means that the channel is really starting to expand and get attention, I guess, on the internet. But anyway, the other one is automotive electronic schematics for Joseph. Please watch those videos. Again, the hands-on how to do. Like I said, starter motor, relays, and circuit. Thanks for watching, everyone.